Hello everyone, welcome back. In this video, we're going to implement a directional dodging system. Most action RPG combat systems have a directional dodging system, so this system is essential for our combat system. First, I'm going to explain on a basic level what we need to do. It's going to start with the player dodge input. After that, we need to check, can the player perform the dodge? If the player can perform the dodge, we play the dodge animation, and then we need to check, does the player have movement input? If the player has movement input, we get rotation from movement input. If the player doesn't have movement input, then we get the character's current rotation. After we get the rotation, we set the actor's rotation over a duration of time. So let's go into the engine and get started. The first thing we're going to implement is the dodge input. So to do that, let's go to Edit, Project Settings, under Input. Let's add a new action mapping. We'll call this one Dodge. And we'll make this input spacebar. However, we will have a bit of an issue because spacebar is also used for jump. But what we can do in that case is for jump, we can just require that the player selects shift, then spacebar to jump. Okay, let's go back to the combat character. Let's add the input action for dodge. So from the flowchart, we know the first thing we're going to need to do is check if the player can perform the dodge. We can just duplicate can perform attack. And call this one can perform dodge. And if the player can perform dodge, let's go ahead and create a function. We'll call this one perform dodge. For this function, we can do the same thing that we did for attack. So go ahead and add two inputs. One is going to be the integer. This is going to be the montage index. And this one's going to be random index. Now let's go to the base weapon actor. Combat system blueprints, actors, base weapon, and duplicate the attack montages variable. We'll call this one dodge montages. Compile and save. For the perform dodge, we just need to do some similar things that we did here and highlight all the things we're going to need for the perform dodge function. Okay, now copy. Let's go to perform dodge. Okay, now let's create this into a local variable. Let's rename this to dodge montage. Now get the montage index. Replace attack index. Instead of get attack montage, let's get dodge montages. Something else that we're going to need to do is, there is no current montage index for dodging, so we're going to need to, check right here if montage index is greater than the last index. If that is true, just select a node here. If that is true, then we get 0. If that is false, then we get the montage index. Now we need to plug in random index here, and we need to replace montage index here. Okay, go ahead and plug that in, compile and save. And let's call perform dodge. Okay, and after the character performs the dodge, we need to do all of these things here, which all this does is gets the correct rotation and sets the rotation over a duration of time. So let's go ahead and implement that. Since we are setting the rotation over a duration of time, a good way to do that is with an animation notify state. Let's go to blueprints, anim notifies, and let's create a new animation notify state. Let's go to blueprint class, type in notify state. We need an anim notify state. We'll call this one rotate character underscore ANS. Okay, I'll save all. Now if you're not familiar with what an animation notify state is, so to explain this, and to add an animation notify state, you can right click under the animation notifies, and under notify state, you can add the one that you want to use. And this is one for like a weapon trail or something like that. Basically, at the beginning, a begin function fires, and at the end of the animation notify state, an end function fires. And if the montage is ended or canceled before you get to the end, then the animation notify state will automatically call the ending function. This is very useful for multiple different kinds of things. In this example of a weapon trail, you could adjust the weapon trail to start and end during the frames of the attack animation. So this is when the swing starts, and you can go to where the swing ends, and you can end the notify state here. If for some reason the character gets canceled out of the montage before the ending runs, it'll automatically call the end. So that way the trail won't stay on forever if you get canceled out of the attack animation. And that's just on a basic level how animation notify states work. So they're similar to animation notifies, but a little bit different. So we can go ahead and remove that now. Let's go back to our rotate character ANS and open it up. We need to open the full blueprint editor. And here we have a few different options. The ones that you're going to use most often are receive notify begin and receive notify end, which allows you to override the beginning and end functions so you can write your own functionality inside of them. But for our case, we're going to use that to set the character rotation. And to set the character's rotation over a duration of time, we're going to need to use the tick function. And for that, we can override the received and notify tick. From the mesh component, we could get the owner. And so what you can do is from the owner, you can just set actor rotation. And here for the new rotation, this needs to be the desired rotation. And the desired rotation is just the new rotation that we want the character to rotate to. But the desired rotation is often different depending on the gameplay scenario. One way that you could do that is cast to combat character. And from here you could implement some function to get the desired rotation, and you could get desired rotation. But we want things to be a bit more modular than that. So what we can do is create an interface for that. Go to Combat System, Blueprints, Interfaces, go ahead and open up Combat BPI. And let's create a new interface function. We'll call this one Get Desired Rotation. In the outputs, we need to change this output to a rotator. We'll just call this output return value. Okay, compile and save. Okay, and now here in the rotate character ANS, we can call get desired rotation. And we can plug this into the new rotation. Okay, now let's go back to the combat player character, and now you can see get desired rotation shows up. Let's open that up. And now inside here, we need to implement the functionality from the flowchart. So the functionality that I'm talking about is checking if the character has movement input. If the character does have movement input, we get rotation for movement input. If the character doesn't have movement input, we get the character's current rotation. So we need to drag out the character movement. We need to get the last movement input vector. We need to check, is it not equal? We need to check, is the last movement input vector not equal to 0? And the error tolerance can be something like 0.001. This just gives us like a tolerance so it doesn't have to be exactly 0.0. Let's go ahead and add a branch and plug that in here. If this is true, so if the character does have movement input, we need to get last movement input vector. This just returns the last movement input vector that was processed by consume input. And from there we can get rotation from X vector. If that is false, then we need to return the character's current rotation. So just get actor rotation. Okay, now compile and save. So what we are doing here is we are first checking if the character has movement input. If the character has movement input, we are getting the last movement input vector and getting a rotation from that. Specifically, we are getting the orientation corresponding to the direction in which the last movement input vector points, and we are returning that as a rotation. If the character does not have movement input, then we simply return the character's current rotation. The first thing we need to do is Combat System, Course Files, Animations, Dodge, and let's first remember to set Enable Root Motion to True, as we're going to rely on root motion to move the character forward. Okay, now let's go ahead and create an animontage from that. Open this up and let's add our notify state. Rotate character, animation notify state. And for the first few frames of the animation, let's rotate the character. Okay, now after we've done that, we need to go to the combat system blueprints, actors, tough sword, and dodge montages. Okay, now add the rolling montage here. Okay, and if we don't have any movement input at all, the character will just roll forward. If we press backwards, the character will turn around and roll backwards. We'll roll right and roll left. But you may notice that we have like an instant snap. But that's not what we want. We want this to be smooth. So how can we smooth that out? The way we can smooth that out is by using a rend_terp to constant. So let's go ahead and right click and open the animation notify blueprint. Let's do rend_terp to constant. So you might be wondering, what is rend_terp to constant? Rend_terp stands for rotation interpolation. The node is pretty simple. It tries to reach a target rotation based on current rotation at a constant rate. So this will prevent the actor from instantly snapping to the target rotation. The target rotation in this case is going to be the desired rotation. And the current rotation in this case is going to be the current actor rotation. So we need to get actor rotation and plug that into the current rotation. For the delta time, that would just be the frame delta time. And for the interp speed, we can just promote that to a variable and leave that as interp speed. And we can make this variable visible so we can edit it from the animation notify state. Let's make the default value something like 720. And so now whenever you go back to the montage and select the animation notify state, you can adjust the interp speed to be whatever value you want. So let's go ahead and test this out. As you can see, that's much smoother. But let's say you want to make that a little bit snappier, a little bit faster. You can set that to something like 1000. You can see it's a lot quicker now. And so with this, you can adjust the value to be whatever you want, depending on the animation. And something else about this animation that I don't like is that it's a little bit slow. So I'm going to set the play rate to about 1.2. Just to speed the gameplay up a little bit. Yeah, that's a lot better. Okay, so one issue that you may have already noticed is that if you spam the dodge button, the character will just continue to cancel into dodge. So the way we can fix that is, let's go to the character blueprint. And let's just create a boolean. We'll call this boolean B is dodging. Okay, and here we'll set is dodging to true. Okay, and now we can add another check here. To check is dodging not. Is dodging not boolean. Okay, compile and save. And now what's going to happen here is once it's set to true, it will never be set to false again, and so this will never be able to run again. But we are actually going to fix that issue in the next video because the system we need to fix this issue has not been implemented yet. So in the next video, when we implement a character reset system, that system will also fix this issue. And that brings us to the end of this video. In this video, we implemented a directional dodge system to our combat system. This dodge system allows the character to dodge in a direction based on the player's movement input. Thanks for watching. In the next video, we're going to implement character reset.